Hello everyone. In this video, let's talk about the power flow diagram of the DC motor and the generator. We will talk about the losses. So let's start with the DC motor. For power flow diagram, we will start from the input and we will continue to output by subtracting the losses, and we will clarify critical power points. So the motor, as you know, which converts the electrical energy to the mechanical energy. Because of this, for the input power, we must write the electrical parameters, and the input will be applied from the terminal voltage. So terminal side voltage and the current multiplication will be the input power. Then the first loss in the system will be the copper losses. I square R losses. We have two resistances in the circuit. The first one is the armature resistance and the second one is the field resistance. So armature loss, armature copper loss can be calculated with the armature current square times the armature resistance, while the field winding copper losses can be calculated with the field current square and the field resistance. After that, the next loss will be the core losses, which are grouped as hysteresis and the eddy current losses, and mostly material related losses are integrated under the core losses. Then the mechanical losses will come. For the mechanical losses, we have friction and the windage losses. Then the last loss will be the stray losses, which is defined as 1 or 2% of the input power. And finally, we have the output power. Output power will be the mechanical power because of the motor operation. So because of this, load torque times Wm will be the output power expression. In addition to that, brush drop losses can be integrated in the first part, in the electrical part. Under the copper losses, you can add. For the brush drop losses, we can use brush drop voltage times the armature current, and brush drop voltage is nearly 2 volts according to real systems. Okay, this is the power flow diagram of the DC motor, but before we skip to the generator operation, let's talk about the critical power points. This dashed line represents the converted power, which shows the electrical to mechanical conversion point. So the converted power can be calculated because of this transition point using the electrical parameters or the mechanical parameters. If we use the electrical parameters, we must use EA, which is the connection point of the electrical to mechanical, and the current which is flowing through the source, EA times IA, can be used as the electrical expression. Or if we use the mechanical expression, induced torque and the motor speed can be used, because induced torque will be transferred to the rotational losses of the system before the output power. And again, as we did in the induction motor studies, we can use the power flow diagram to clarify the power relations. For example, output power must equal to input power minus copper, minus core, minus mechanical, minus stray, and minus brush losses if we have. Okay, what about the generator? For the generator, the content of the power flow diagram and the expressions will not change. The only difference will be the direction of the current flow. Instead of electrical to mechanical, we have a mechanical to electrical power flow. So because of this, for the power flow diagram of DC generator, between the input and output power, the first loss of the generator will be the last loss of the DC motor. So we can start with stray losses, then the mechanical losses. After that, core losses. And finally, I2R losses, copper losses can be used. Again, for the I2R losses, we can use the armature I2R RA, IF2RF, and brush drop losses, brush drop voltage times the armature current can be used for the total I2R total copper losses. And input output powers. For input and output, DC motor input power will be the input power expression will be the output power expression of the DC generator. That means VT times IL, which is the DC motor input power expression, will be the output power of the DC generator because of the operation reversal issue. Similarly, for the input power, we have a mechanical power. Because of this, applied torque times Wm must be the input power. And between this core losses and the I2R losses, again we have the converted power, and the same expressions can be used, EA/IA with the electrical parameters, or induced torque times Wm can be used for the mechanical parameters to calculate converted power. Thank you for watching.